So we were doing May June 23 paper 4-2, and we have completed the 2 questions in the last session. And today we are going to complete this paper. So let's move to question number. That question number 3 is basically based on the test of ions and gases. And for that, the examiner provide you the list of the test for cations and anions and the test for gases at the end of the paper. Okay. So a student investigates solution W and solid X. Solution W is green in color and contain Fe2 positive ions. Okay, so that is very important thing for you guys to understand. If for paper 2 and paper 1 as well, because in paper 2 and paper 1, uh, you know, uh, they didn't give you these tests. So remember, if the iron 2 positive ions present in the aqueous solution, then you are going to observe the solution is green or pale green. Okay. And in the same way, when there are Fe3 positive ions present in the aqueous solution, you are going to observe a solution red or orange solution or reddish yellow solution. And in the same way, when these two ions forms their compounds, which are, water insoluble, so their precipitates formed are of the same color. If the iron 2 positive ions has a compound which is water insoluble, so you are going to observe a green color, a green precipitates. And with iron 3 positive, red precipitate. Okay. Now, what they are saying, describe how W can be shown to contain Fe2 positive ion. Yes, very good, Amal. Your answer is right. See, if I'll show you at the end, these cations and anions and their tests are provided to you, right? So, see, they have mentioned that you have to identify for this one. So for this one, we have a test with aqueous sodium hydroxide and we have a test with aqueous ammonia. So we can use any one. So in both of them, if you see green precipitates insoluble in excess. So it means where initially we add a small amount of sodium hydroxide, we are going to observe the green precipitate. And when we add excess of sodium hydroxide, so these precipitate doesn't dissolve, they remain insoluble. Is this understandable? And in the same way, if you add aqueous ammonia, a small amount of aqueous ammonia, you are going to get the green precipitate. And when the aqueous ammonia, we dissolve it in excess, there remains insoluble in excess. It means on adding excess, these precipitate doesn't dissolve. So you have to write this. You have to check the table for paper 4 and then write this. So over here, I'm going to write you can use any one, either aqueous ammonia or sodium hydroxide. So add aqueous sodium hydroxide green precipitates are observed and remains insoluble in excess of sodium hydroxide. Is this understandable to all of you? Now, excess W is added to acidified potassium manganate. Describe the color change seen. So, yes, the color change is Yeah. So see, potassium magnate is an oxidizing agent, right? So if it's an oxidizing agent, and as we know, W contains Fe2 positive, so on adding potassium magnate, it turns Fe3 positive, right? So as we have discussed earlier, that here it's a pale green, and here it's a yellow solution, right? And the color change. Potassium magnate is a purple color, so it changes its color from purple to colorless. So what happened over here? Yes, Zainab. Okay, there is another thing that I will clear, Heather. We will not going to write red over there. Let me tell you why. Because the red are the precipitate. So it's better to remember like this, that because when it's solution, the iron 2 positive ion are usually diluted. So we get a yellow solution. And when it forms as a precipitate, so the precipitates are reddish brown or reddish yellow. Okay, reddish brown precipitates have been seen. So see, so the initial color would be purple, right? And the purple decolorizes. So at the end, we will get a colorless solution, right? But the iron 2 positive is turning into iron 3 positive. So which color dominates at the end? The colorless and the yellow. So we are going to observe the yellow solution. So the color change would be purple to yellow. Is this understandable to all of you? Yes, very good, Zainab. Okay. Now, describe the observation made when a few drops of aqueous ammonia and then excess of aqueous ammonia are added to mixture from 2. Okay. Yes, these color changes for the oxidizing agents that you have to remember. These color changes you always need to remember, except the ones which are provided at the end of the paper. Okay. Now, so in 2, what happens? As we know, iron 2 positive turns into iron 3 positive. Now, in this solution, what we have iron 3 positive in it. Now, if in this iron 3 positive, if I add aqueous ammonia, see what will happen. The reddish brown precipitates have been formed. See, if there is a iron 3 positive and we are adding aqueous ammonia, so the red brown precipitates and insoluble in excess. Yes, very good, Zainab. So is this clear to you? So with few drops, we will write red brown precipitates, and then in excess we will write uh, precipitates remain insoluble. Is this understandable to all of you? Okay. Now, B part. Solid X is a shiny gray metal. So see, it's a metal. For a metal, don't have any tests in the table provided, only for the positive ions and the negative ions. The test that the student does on X are shown in table 3.1. Okay. For the metal, we can use the flame test from there. Okay. Some of the observations for these tests are shown below. An excess dilute acid to add excess dilute acid to X in a test tube, the gas produced is tested. Okay, so see, they have given you the solid disappears, solution remains colorless and becomes warmer. So what is the gas? Can anyone identify the gas? When a metal and acid reacts, which gas is formed? Yes, very good, Amal. A hydrogen gas is formed, right? And for hydrogen gas, if you recall the test, we know that we use burning splint and the observation would be pop sound, right? Yes, very good, Zainab. Mustafa, very good. Okay. Now, in the second part, add dilute nitric acid, then add aqueous silver nitrate to some of the solution from test. Okay. Yes, but oxygen doesn't perform when you add when you react acid and a metal. So that's what you need to understand from the chapter acid and bases, that when acid reacts with the metal, we always get salt and hydrogen. So see, they have mentioned you that X is a gray metal, and here you are adding acid. So if acid and metal are being mixed, there is no way that oxygen would form. Okay, Heather? Okay. Add dilute nitric acid, then aqueous silver nitrate to some of the solution. Solution remains colorless. So what does this indicate? Yes, Amal, very good. So see, what we are adding, nitric acid and silver nitrate, right? So see over here, if you look at in the table, here you go. Nitric acid and silver nitrate, nitric acid, silver nitrate, nitric acid, silver nitrate. White precipitates if chloride is present, cream precipitate if bromide is present, yellow precipitate if iodide is present. But there, yeah, very good, Zainab. So what we can conclude from this, that as they have seen mentioned, that no solution remains colorless, so it means no halide ion is there. And what does it means? No halide ions means no chloride, bromide, or iodide is present in the solution. Is this clear? Okay. Now, yes, Amal, good. We add a dilute nitric acid, then we add a aqueous barium nitrate to some of the solution from test one. Okay. So what we observed? White precipitate. So see over here, if you look, what we did now, dilute nitric acid and barium nitrate, right? And we are getting white precipitate on this, so it means it's a sulfate. So from here, what we can conclude, it's sulfate. Is this understandable? Remember, doesn't white precipitate form chloride, means chloride as well, but when you add nitric acid and silver nitrate, then white precipitate means chloride. But if you add barium nitrate, nitric acid, and then you will get white precipitate, it means it's a sulfate. So from here we can conclude it that it's a sulfate. Okay. Now let's move to the questions. Predict the identity of gas produced in test one. Describe how the student tests gas to confirm its identity. So yes, we already knew because we did our homework. It's a hydrogen gas. And if you guys recall the test, we already discussed it. Burning splint and pop sound would be here. Is this clear? The observation for test one are incomplete. Okay. State one other observation that the student makes for test one. Yes, very good, Amal. See, as the gas is produced, so we are going to observe effervescence, but I suggest, yeah, very good, Zainab. Instead of using the word bubbles and fizzing, I'll appreciate if you will write effervescence. Okay. So the other observation would be effervescence. That is missed because yes, that's what I try to make and explain it to Heather as well. CZ, what is X? X is a gray metal. X is a metal, right? And what we are doing over here, we are reacting X with the acid. So it means we are the reaction is between acid and a metal. So when an acid and a metal reacts, we know a salt is formed and a hydrogen gas liberates, isn't it? So see, that's how we know we identified that the gas is hydrogen. Okay. Now, state the conclusion you make from test 2. So we already did that conclusion that we concluded that no halide ions are present, right? Because the solution stays colorless on adding silver nitrate, no precipitates have been observed. So no halide ions are present over here. Now, state the conclusion you make from test 3. In test 3, when we added barium nitrate, we got the white precipitates, and from that we concluded that the sulfate ions are present, right? Sulfate ions are present. Okay. Now they are asking identify the acid used in test 1. Yes. Yes, very good, Zainab. Very good, Amal. See, as the sulfate ions are here, now try to, try to follow from the start. X is what? It's a metal, right? So metal is an element, right? And in X we have added acid and we don't know the acid is. But after that, mixing with the acid, when we added barium nitrate, we get the white precipitates of barium sulfate and we have concluded sulfate. So from where this sulfate came? Acid. So it means the acid would be sulfuric acid, H2SO4. Is this understandable to all of you? Yes, Mustafa, very good. I hope it's clear to all of you. Now, identity of metal X. So metal X is reacting with the acid because if nitric acid is there, then how could we get a white precipitates of barium sulfate? If nitric acid was there, then we didn't able to get this night sulfate ions, and on adding this thing, we are again going to get the colorless solution. There would be no white precipitates over here. But zinc sulfate is a compound, right? And here they said that it's a gray metal. They have clearly mentioned that it's an element, it's not a compound. Which table, Amal? Yes, it's magnesium. Okay, but it can be, uh, we can use zinc as well. So the thing is that what you have asking Khatija, that if instead of C, if this acid is nitric acid, let's suppose, and you are adding barium nitrate in it, then on adding barium nitrate, we are going to observe a no change, right? Because barium nitrate reacts with the sulfate ions to form barium sulfate. And here, when we have added a barium nitrate, we get the white precipitate. It means that the sulfate ions are present. So from where do the sulfate ions come? Because there is a metal only. So it means that the acid that we have used is sulfuric acid and which contains sulfate ion. Is it clear? Okay. Now the metal is reacting with an acid. So acid from acid, the hydrogen is get substituted. So the metals which the elements which are above uh hydrogen can be the one. Okay, now we cannot consider here iron because Heather, you said iron. And listen, why it's not iron? Because see, what is the color of the metal? Gray. And if you recall, iron is not gray, basically. Iron's color is silvery. Okay. But the gray color is of zinc and magnesium have a gray color. Yeah, we cannot use group 1 and a calcium because they are not, yeah, the group 1 are gray, but they react explosively with the acids, so we cannot react them in the lab. So the metal X would be magnesium. Instead magnesium, you can write zinc as well. Is this clear? Yeah, usually if you recall, the metals are either gray or some metals are silver, or except 2 or 3, you know, the one which are like gold has a different color and copper is a pink solid. Beside this, most of the metals are almost gray, except, iron and silver, which are silver in color, isn't it? Okay. Now see, the total paper, the question is of 40 marks. See, this question contains how many marks? 14. And the titration question we did in the last class contains 14. So see, 28 marks are secured by these two questions only. And now you are left with only 12 marks. And from 12 marks, you already secured 6 marks over here because if you recall, this was the very easy question. So you are just left with the 6 marks. And in this 6 marks, the last one, the designing of the experiment, most of the students did mistake. For this question, you guys have to keep follow the whole thing from the start, the whole instructions. So, let's start with this question. Baking soda is used to make bread rise. When baking soda is heated, it decomposes and carbon dioxide is released. Okay. Just give me a minute, please. Okay. Now, baking soda also decomposes gradually when it is stored. So it means that if you leave it and keep it for some time, it continues to decompose. The longer the baking soda is stored, the less the carbon dioxide it releases when it is heated. See? So when you keep it for a long time, almost most of the baking soda has been decomposed. So when we use it for a baking purpose and we try to heat it, it will produce a lesser carbon dioxide. I hope till here, is this understandable to all of you? Yes. Yes, Mustafa. Now let's see. plan an investigation to show which of two different samples of baking soda has been stored longer. So it means you are provided with the two samples and you have to identify out of those two, which one is kept for a longer time. Is this clear to all of you? Yes. Now, your plan should include the use of a common laboratory apparatus and the two samples of baking soda. No other chemical should be used. Your plan should include the apparatus needed. Okay. So first talk about the apparatus. What apparatuses we need? If we are using two different samples, yes, yes. So we have to make sure that we use the same mass of both the samples. So it means we are going to need a balance. We have to heat the baking soda to make the carbon dioxide gas released. So for that, we can use Bunsen burner. Okay. Beside this, if we are heating it, we are going to hold it in some apparatus like test tube. So we need a test tube as well. Yeah, and as the gas is formed, that gas must be collected in some container, and that container where we can have to measure the volume. So gas syringe. Very good. So most of you guys have identified most of the things. So see, these are the important things that you need. So we are done with the first thing. Now, in the next one, they ask you the method to use and measurements. Okay. So when we explain the methods, we are also stating which measurements we are doing. So these two are interconnected with each other. So see what we will do. First, we record the mass of samples. Then what we will do after doing this, we heat the samples and then what we will do, record the volume of gas formed. So see, we are done with the method and measurements. Now, next is the variables to control. So what are the variables that we needed to control? As we have discussed earlier, there are two samples. So same mass of both sample. No, they have already told you, Mustafa, that you are given with the two samples and you have to identify which one has kept for a longer. So they didn't ask you to store them. You have to identify among between these two, which one is stored for a longer. So we are just doing the experiment. We are going to measure the volume for both the samples. When we see which one produces the greater volume of a gas is the one which is stored for a smaller time, and the one which produces the lesser volume of a gas is the one which, uh, stored for a longer time. Yes, very good. The other thing, heat to the same temperature. And heat till no further change is observed or the reaction is finished. So any other thing that we have to control? Yeah, heat for the same amount of a time. If Zainab, you are going to write this, you will be penalized because you didn't mention the stopwatch earlier. So if you are planning like that both the things would be heat for the same time, then you have to mention the stopwatch at the first phase. They are both mostly in the same form, Khatija, so there is no need to write this. So we are done with the variables to control as well. Okay, now the last one, how to use the results to determine which sample has been stored for longer. So see, we have recorded the time, right? So I can write sample which produces lesser volume of gas is the one kept for longer time. Is this understandable to all of you? What, Amal? How? Read this again. Baking soda also decomposes gradually when it is stored. The longer the baking soda is stored, the less carbon dioxide it releases when it is heated. So because we kept it for a longer time, so most of the carbon dioxide has already been lost. Read this. Read this thing for the last, for the conclusion. They are saying when baking soda is heated, it decomposes and gives carbon dioxide, right? Baking soda also decomposes gradually when it is stored. So it means if there is a baking soda and I kept it for a month or 2 or 3 months, then obviously it gradually start decomposing and it releases carbon dioxide. So most of the carbon dioxide has been released. Now I take it out after 3 months and I am going to use it for the baking purpose. When I heat it, it is going to produce the lesser carbon dioxide. Now, is this understandable to all of you? If any one of you has still any problem, any confusion, please ask. Okay. So here we are ending the class and we are going to start the structured question paper from the next class. And probably I'm going to take the next class 9 p.m. PST tomorrow. Okay. So you see you guys everyone tomorrow. Take care. Allah Hafiz.